Hello and welcome back to another episode of Math with Son. Today, we're going to be finding out how to write an equation of a line. There are two formulas that you can use to your advantage. One of them is y equals mx plus b, and the other one is y minus y1, m parentheses x minus x1. Now, both of these have their own benefits. This first one, y equals mx plus b, is known as slope intercept form, and the other one is called the point slope form. Now, if you are given your slope and your y-intercept, you're going to want to use y equals mx plus b because m is your slope and b is your y-intercept. But if you were given a point and your slope, you would want to use the point slope form because the m is still your slope and that x1 and y1 is your point. All right? So, for our first example, let's say we were given a slope of 3 over 2 and a y-intercept that is equal to -4. If you're given that information, all you have to do is plug it into the slope-intercept form, and that would give us y equals 3 over 2 is our slope, x minus 4. And that is all that you need to do. That is if you are given a slope and a y-intercept. Now, if you're given a point and a slope, let's say that it has to go, your line that you want to write has to go through -3, 5, and you have a slope that is equal to 2, then you would need to use the point slope formula. So we're going to fill in our y minus y1. Well, 5 is going to be y1, so y minus 5 equals slope 2 x minus my x1, which is going to be minus -3. When you have a minus and a negative, you're going to need to change that to a plus, so we end up with y minus 5 equals 2x plus 3. You can stop right there. You do not have to go any further unless it is required. And for me, it will be required some of the time. It will not be required all the time. And this is an example of if you have to do the bare minimum, you stop there. And that's okay. It's in point slope form. It doesn't have to be in slope intercept form all the time. We're going to do two more quick examples, and on both of these examples, we're going to do the same thing that we just did, but we're going to just take it a little bit further. So let's say that I wanted to write an equation of a line that is parallel to y equals 3x plus 7,128, and I want it to go through the point for -3. Actually, I'm going to make that -13. For -13. So you have a slope given to you in disguise. If it is parallel to this line, then you just need to say, oh, wait a minute, it needs to be parallel, and that slope is equal to 3. If it is parallel, my slope is going to also equal 3 because parallel lines have the same slope. So we have a slope and a point, or a point and a slope. Therefore, we will have to use our point slope formula. So we're going to plug in our m and our point for x1 and y1. So that would be y minus a -13, that's going to turn to plus 13, equals 3, and then the x minus 4. We're going to change this to a plus 13 equals 3 and the x minus 4. And we can circle our answer. Now, this is 100% perfectly acceptable. If for some reason you need this to be further down and turned into y equals mx plus b format, the slope-intercept form, then all you would need to do, if you are expected to go further, which on some problems you have to, is distribute y plus 13 equals 3x minus 12 And we just did that by doing 3 times x and 3 times negative 4. Move that 13 over, and we'd get our answer. Y equals 3x minus 25 when you subtract both of those. So both of those are acceptable answers, and both of those just have their own merits. Our last example, we want it to be perpendicular to a graph. And on this graph, I'm going to have the slope currently be up by 1 and over by 1, 2, 3. So I want it to be perpendicular to that graph. Sorry, you didn't get to see a little bit of there. So perpendicular to that graph, we went up by 1, over by 3. So if the current slope right here of this graph is up by 1 and over by 3, what would be perpendicular to that? Well, perpendicular to that would be negative 3 over 1. And that is the slope that we will care about. So it's going to be perpendicular to this graph. Check, we got the perpendicular slope. And I want it to go through this point right here at 1, 2. All right, so I want it to go through this point and be perpendicular to the graph, which we already got the perpendicular slope. So we have our point, we have our slope. Let's get our equation. Y minus y1 equals m parentheses x minus x1. Plug in the slope, which I'm going to really just plug in negative 3. I don't need to put it over 1. And plug in that point. Y minus 2 for the y1 would equal my slope, negative 3. We found that perpendicular to the line provided, x minus 1. For this problem, I want to distribute. I don't have to. I could circle this and call it a day, but I want to personally distribute to show you something. Y minus 2 equals negative 3x plus 3. Add the 2. Add the 2. Y would equal negative 3x plus 5. Now, the reason I wanted to show you that is if we were to graph negative 3x plus 5, it would be up by 5 for my y-intercept. And I would go down by 3 and over by 1 and down by 3 and over by 1 and down by 3 over by 1. It eventually would cross the line that was given at a 90-degree angle. All right? That's going to do it for today's episode. I will see everybody later. Have a great day. Bye.